Okay guys, so let's try and understand motion of vehicle along horizontal circular road. Horizontal road, circular road, and the vehicle is moving around in that circular road, in a horizontal circular road, because later on we'll also be observing circular road but banked. So it would be at an angle, alright, theta, at an angle theta, and the vehicle would be moving like that. Alright, so here what we are talking about is horizontal circular road. Fine. Now just visualize a vehicle moving like that in a circular motion. Now you know when it is moving in a circular motion, the tires which are there, they're experiencing some friction inside. Alright, and the vehicle has tendency to fall outside whenever it is moving in a circular motion. So think of its velocity increasing and then toppling out. Alright, now why do you think? Just think over it. Why does it happen? Because initially when the velocity is controlled, the frictional force of tires which are on the road is preventing it from falling. When is this frictional force not able to control that vehicle from falling out? When the velocity has increased, has crossed the maximum limit. Whenever the velocity has crossed the maximum limit, the frictional force can do nothing about it. The vehicle topples out. Fine. So let's understand what's the mystery behind that. Alright, so when the vehicle is moving in a circular road, obviously horizontal, there's a frictional force acting in this direction, inside direction. And what is that force which is trying to topple the vehicle? Obviously it is the centrifugal force. We know the formula. It's mr omega square or mv square over r. V in terms of linear velocity, omega in terms of angular velocity. Fine. So we know this. So whenever the vehicle is moving, frictional force and centrifugal force have to be in equilibrium with each other. That's what we have tried to show over here. Static friction, Fs, equilibrium with each other. That is what I have tried to show it over here. Static friction, that is Fs, designated by Fs, is equal to mr omega square, or is equal to centrifugal force. Alright, so these two are the formula for rotational and translational centrifugal force. Fine. Okay, that's about. What about this? Now I need to explain you over here. Whenever a body is kept on, any body kept on floor, normal balances the mg. Mg is always, towards the center of the earth. Mg is balanced by normal. Earlier videos I have tried to show that how if normal reduces, the body starts flying. Alright, I have given example of lifts and all. Please refer those videos. Alright, so the body is at rest. It's on floor over here. I am applying force in this direction. Alright, frictional force would always be in the opposite direction. Now you might have read that frictional force finds its own direction. What does it mean? Now suppose if this is lying here, I'm applying force this side, right? So frictional force would be in this direction. Now if I'm applying force like that, upside, right? So frictional force would be in the opposite direction. Alright, so frictional force finds its direction because when it was like this, the friction force, because when it was like this, frictional force was in this direction, and when it was like this, frictional force was in this direction. So frictional force finds its own direction. That's a different aspect. Alright, but has to be borne in mind always. Alright, fine. Now here, so whenever I apply force this side, friction force. So that's what we saw over here. The force which was trying to pull it out was centrifugal force, and that centrifugal force was balanced by frictional force. So that part is covered up. But what I want to get into is frictional force is directly proportional to normal, because the heavier a body is, more would be the normal. Heavier the body is, more would be normal, and so more would be the friction. So think of a heavy body here you are trying to pull it out. Think of a light body over here trying to pull it out. Obviously, heavy body will require more force. Why? Because the frictional force also would be greater. Lighter body, lighter force. Why? Because frictional force also would be lighter. Alright, so, and that heaviness is again dependent on normal. More mg has to be more n, because n is in equilibrium with mg. Done. So Fs is directly proportional to normal. So we know when proportionality constant goes, we know when proportionality sign goes, a constant gets in. Now this constant here is called as coefficient of static friction. Mu s is coefficient of static friction. So Fs is equal to mu sn. So Fs over n is mu s. This is what we would be requiring over here. Alright, fine. So now what we do is we got this equation, n is equal to mg. N is balancing mg. Frictional force is balancing the centrifugal force. Done. So we divide this by this. So Fs over n, mr omega square over mg, or in terms of linear, mv square over r. So this r is of this r and mg. Alright, m cancels as you see everywhere. So it becomes Fs over n. Now Fs over n, we can also write it as mu s. Fs over n, we can also write it as mu s is equal to v square over rg. V square over rg, we are talking in terms of linear, right? V square over rg, we can convert that into angular also. V square over rg. V square, we keep it this side, rg we take it that side. So v square is equal to mu s rg. Rooting both the sides, we get maximum velocity when a vehicle moving along horizontal circular road has to be root of mu s rg. Alright, now mind you, MCQs they would ask you, so what all velocity, maximum velocity on a circular road depends on what? Obviously it depends upon g is constant, unless you are driving in moon where g is 1/6 of what it is here. Alright, so what would happen there in moon? G is 1/6. 1/6 means whatever value is there, much lesser than that, and directly proportional. So velocity required there would be lower. Maximum velocity required for a circular motion to move in without skidding is much lower. Alright. Okay, now let's talk in terms of static friction. Wherever the road is rough, static friction is high. Wherever it is smooth, static friction is low. Wherever it is oily, static friction is still lower. Alright. So wherever it is oily, you in a circular motion, you have got to carry on with very low velocity. Wherever it is not oily but smooth, you can go in with a slightly higher velocity than when you are moving in a oily road, oily horizontal circular road. Now when you are moving on a rough surfaced road, obviously Vmax could be much higher than oily or even much higher than plain. I hope this concept is clear. So this depends on static friction, directly proportional. Alright. Similarly, it is also depending upon radius. Smaller the radius, smaller the velocity with which you have got to move. Alright. And bigger the radius, higher the velocity with which you can cover the circular horizontal road. I hope the concept is very clear. This was about MCQs, and now we are going to use it for numerical purpose. I hope it's all very clear. Okay.